Okay, so yesterday we talked about how to calculate speed and velocity, and we learned that the calculation for speed and velocity is exactly the same. It's distance divided by time. Except for velocity in your answer, you have to state the direction that the object is moving. Okay? Today we're going to learn how to graph motion. Okay? So when we graph motion, we use a distance versus time graph. Alright? And on our horizontal axis, we label it as being time, okay? The vertical axis is labeled with distance. So, as a rule, the horizontal axis always represents an independent variable, and time is an independent variable. No matter how fast or how slow an object moves, time's not affected by it. Time still goes on, okay? But distance is affected by how fast or how slow an object moves. Therefore, distance is considered a dependent variable. So, dependent variables are always on the vertical axis. They also call it the y-axis, or vertical axis. It's a dependent variable, okay, for the graph. And in this case, in the distance versus time graph, that is distance. And as I said earlier, the horizontal portion of this graph is time, because it's an independent variable. And independent variables are on the horizontal axis. All right? So, when you graph the motion of an object, well, what you're graphing is its distance over time. You're graphing its speed, okay? And the speed of an object is represented by a line on the graph. If an object is moving at constant speed, then the line will be perfectly straight because it's moving at a constant distance per time, all right? Now, the slope could be steep, or the slope could be more of a horizontal slope. If the slope's more of a horizontal slope, well, the object's moving slower. Like, let's talk about a car. If a car's moving maybe at 35 miles per hour, its slope could look like this. But if another car is moving at 65 miles per hour, its slope would be steeper on the graph, okay? And again, I'm talking about constant speed here. It would be a straight line for the slope. Now think about this. You're on the road, and you're rarely going at constant speed, especially if you're in town. You may stop at stop signs, you may slow down or speed up, and that can all be represented on the graph too. That would not be constant speed, however. It would be average speed. It would vary, okay? So, say you're driving in the city, and you're going 35 miles per hour, and then you slow down because there's traffic up ahead. You slow down to 15 miles per hour, so the graph would start going down like this. And then you speed up because, you know, there's a little bit more room in front of you. So, and here comes the stop sign. So, at the stop sign, the graph completely goes flat. There's no motion, there's no distance going on. Time's still going on, as you can see, but distance is not happening. There's no increase in distance, so the graph is flat. Completely flat line when an object stops, like a car. If it stops, it would have a completely flat line on the graph. But as it speeds up, the graph goes up or down, depending on the speed, okay? And that is how you graph distance versus time.